I'm Paul, and I'll be talking about my time at 38 Degrees and my foray into the world of natural language processing, or NLP. So a couple words about 38 Degrees. They're a non-profit organization that campaigns its approximately 2 million members to help out with various issues such as Brexit and the NHS and your local library closing down. I think my favorite recent success story is a campaign that was successful to increase the blue band around the UK by, I think, double, and thus improves the protection of marine life in our coastal regions. The way that 38 Degrees do this is by sending emails. Oh, thanks. There we go. Is by sending emails to its members, encouraging them to perform an action. And so predicting the email success and being able to tailor the emails as best as possible is a huge lever in 38 Degrees' ability to provide impact and successful campaigns. So because emails are complex items and there's many ways to write an email, we thought that it must be possible to apply data science to better predict an email's success. So an example email with all the different factors and features that explain its ultimate success or click rate. Some of these features are relatively easy to picture and to visualize. So for instance, the word count is somewhat negatively correlated with email success. I guess we're lazy and don't read the long emails. Similarly, various issue categories perform consistently better on average than others. Again, no huge surprise. But it's not clear what to do with all the language features in the email themselves. So here we have to start getting a little bit clever with things. The way that we generally perform analyses on language features is by text embedding, and there's many ways to do this. So for instance, a word can be embedded in one of many ways to be represented as a number format, and similarly you can do things to sentences to turn them into numbers. And the goal is to provide a set of numbers that represent the linguistic information and allow us to apply machine learning techniques to them. Right, so these are some of the text embedding techniques that I was able to trial out in this project, and I've tried to order them here in some ranking of increasing sophistication. So we'd expect that our predictive capacity should improve as we move along this axis. Similarly, what to do with all these numbers is also a matter of choice, and the various algorithms that I tried are listed here again in some ordering of what I have experienced to be increasing sophistication. So I've tried to build up the picture of what models I could build to predict email success, and here we see a surface of the prediction error that my model gives in various combinations of the features that are used and the algorithms that are used to fit them. And interestingly, the initial use of language features led to an actual worsening of my model's predictive capacity. What I think is happening here is that I'm introducing a fair bit of noise that the algorithms can't sensibly handle. But luckily, as we move towards even more sophisticated models, we were able to actually preserve some of that information clearly and reduce the fit error that the model gives. Ultimately, I was able to arrive at this point here where the model's prediction was 50% more accurate than a simple naive median estimate and 30% more accurate than a model that didn't include any of the language features at all. So I am of the opinion that clearly machine learning can be applied to predict email success rate and the click rate that we should expect from an email. And the language models that are available are good for this, but of course these are now being developed further and further, so I see that the potential for better models is only growing. And ultimately, I hope that the work I've done will provide the foundation for a tool or a set of tools that will allow 38 Degrees to provide the best and most impactful emails to its members and hopefully save the world. Thank you very much.